Magnetar flares are more than just cosmic fireworks. They might be the universe's factories for heavy elements like gold and uranium. Recent studies reveal that these colossal bursts from ultra-dense remnants of supernovae could account for up to 10% of the heavy elements in our galaxy. Imagine, every time a magnetar erupts, it's not just a spectacle, it's potentially creating the building blocks for planets and even life itself. For decades, we've speculated about the origins of these precious metals, but now, with decades-old telescope data, we're uncovering the truth. These magnetic monsters could reshape our understanding of galactic chemistry and the very fabric of our universe. Magnetars, the cosmic powerhouses born from supernovae, are not just exotic neutron stars, they might hold the key to understanding galactic formation. With magnetic fields so intense they can twist atoms apart, these dense objects play a crucial role in creating heavy elements through the R process. The 2017 collision of neutron stars provided groundbreaking evidence of this process, but it turns out that magnetar flares could also eject heavy elements into space. A stunning example is the SGR 180620 flare, so bright that we measured its light bouncing off the moon. This discovery reshapes our understanding of how galaxies evolve, highlighting the overlooked yet vital role of magnetars in the universe. Magnetar flares are fascinating cosmic events that hold the key to understanding our universe. When these powerful bursts occur, they eject heavy R process elements, and researchers have found that the radioactive decay of these elements aligns perfectly with their predictions. This connection not only sheds light on the energies released during flares, but also hints at the origins of heavy cosmic rays, those mysterious high-velocity particles we still don't fully understand. Moreover, magnetars play a crucial role in galactic chemical evolution. They create essential elements like gold and silver, and their explosive deaths enrich the cosmos with vital materials like oxygen and carbon. This means that billions of years later, the atoms from magnetars could be part of the very building blocks of life on new planets. Isn't it incredible how these cosmic giants contribute to the fabric of existence?
Fast radio bursts, or FRBs, are these mysterious flashes of radio waves from distant galaxies, and they hold the key to understanding cosmic evolution. Recent findings suggest that studying magnetars, supercharged neutron stars, could reveal how heavy elements are formed in the universe. The challenge? Magnetar flares are rare and fleeting, making them tough to catch with current telescopes like Hubble or even the James Webb. But there's hope on the horizon with NASA's Compton Spectrometer and Imager, or COSI. This mission aims to scan our Milky Way for energetic events, potentially allowing us to identify the elements produced in a magnetar flare. If we can observe one up close, we might finally confirm where those heavy elements come from. It's an exciting time for astrophysics, and the discoveries ahead could reshape our understanding of the universe.